Hello YouTube, this is Stick 152. Today I'm going to be doing a demo of some of the new features I've added to the Signal Communications Pack, Radio and Morse. This is for the 1.1 version that's coming out soon. So the new features are a Morse decoder and a loss of signal zone and a frequency jammer. So for the, like in this case, this is the frequency jammer. So what you do is you provide a tag, and you can specify what this tag will be. This is just what I named it. For the object that you want to be the zone, you just give it a sphere or a collider, or any kind of collider, and just make sure it's a trigger. Set up your radius on it. Because of the way these colliders work, one of the other objects, or one of the objects that collide with it, has to have a rigid body. And so in this case, I've just given it a kinematic rigid body directly on it, just for ease of doing this. Same thing for the loss of signal zone. Same thing, just a collider set up as a trigger and a rigid body set as kinematic. Okay, the way these work, this loss of signal zone, essentially the radius affects how much you lose as you come in. Like if you have a really small radius, you may not lose all of the signal. If you have a larger radius, you might lose everything. And the jammer works just like it sounds. It just doesn't allow any transmission or reception inside the zone. Okay, so for this guy, we want to be, this is our listening object. So we want to go ahead and add a radio component to it. You just drag and drop that, and you're done. And then for this guy, we want to have a Morse code auto emitter. So we go to the Morse code, drag an auto emitter onto it. And we're going to set this up for radio. I'm going to flash the material just so we can see it. Everything's good here, except I want to make 20 and just a 1 second delay. And that broadcast delay is the time between broadcasting this message over and over again. If you have the times to send set to -1, it just sends this infinitely with a 1 second delay. Okay, so we'll up our effective range here. And our band selection is 1.8 megahertz, and it's the same thing on the radio here, 1.8 megahertz. Okay, and we'll go ahead and open the Morse decoder over here. Alright, so let's play this guy. Okay, so I'm going to move this into the jammer, and you'll see that it went away. So it can't receive or transmit. So if you take the transmitter and you move it over there, it works the same on it. So now we're going to go over to the loss of signal zone. So you can hear that it just applies an extra distance to the high pass filter that it's putting on it. Let me explain that a little more. So as I move the listener further away from the transmitter, it will naturally get a fall off in the signal. So the signal, you get a loss of signal naturally just from distance. What the loss of signal zone does is it actually adds on top of that. So if I move the same distance away from the transmitter outside of the zone, you'll have one fall off. But if I move that same distance but into this zone, it'll have a greater fall off. So you can affect that and make that worse by going in here. And here you can specify the tag that you'll use for the loss of signal zone, and you can also do a fall off scaler. So if I adjust this fall off scaler, say I move this guy in here. So when I'm right on top of it, I only get so much fall off. But if I adjust that up, so I get way more fall off as I come in. And that's pretty much it for those two features. Now for the Morse code, if you watch this guy, as it starts decoding, it auto detects the words per minute, and it decodes the letter based on the length of the dit or the da. So if I go in here, the transmitter, and I up it to like a higher word per minute, like to 30, you can see that it's up to 30 words per minute, and it's still decoding. There's a couple of things here. The fine tune, the delay fine tune, that's in the automated mode. That's going to be for if you have any delay on your network, if things are kind of sluggish, you can tweak that. And that's the time. It sets up the time between characters or between letters, so that it knows when to sense it. So it just uses that in the algorithm that it uses to determine when it thinks you're done sending dits and das that make up a letter, so that it can actually try to decode it. The max tone length value, that's the maximum length of a sound that we would consider as a Morse code tone. Because this radio component can receive voice over microphone, it can receive Morse code, it can receive radio broadcasts like music and stuff like that. So it needs some way of telling what's Morse and what's not. So I'm doing that by just basically setting the length of the signal. So anything over this length, it won't even try to process it. The decoded text length, essentially what it is there's a padded field for this decoded text. It's padded with this many spaces. And then as you start getting Morse coming in, it just scrolls the text over from right to left, and fills the screen with all the text as it scrolls by, as you saw in the demo there. Okay, so now that's the automated reading auto-generated Morse code. Now let's see what it looks like when you're trying to do hand-generated Morse code. That's a little more complicated here. Okay, so turn this down. Now you can use the auto decoder, the auto words per minute for the hand generated Morse code, but I'll show you what happens if you do. So this test receiver, this is on CB channel 1 like that, and it's just got the decoded Morse. Another thing I added with the decoder feature is I added hooks into the UI manager. So this pack ships with a built-in UI manager that you can use. I just provide it as an ease of use thing. You can use your own, but I've got this hooked in just in case somebody wants to use it. So we've got it set as auto, so we're on the test receiver. So we've got it set as automatic word per minute. And if I start hitting my Morse code key, you can see that changes. So that character, if you watch that decode word per minute value, so it's really difficult. You have to send like very precisely. In reality, I found that a tenth to a hundredth of a second difference in your tone lengths can change this word per minute all over the place. So for that, if somebody's sending by hand and you want to be able to copy it, what you can do is turn off the automatic. I'm going to set this down at like 15 words per minute so it's easier for me to send. This is where the delay fine-tune really comes in handy. So if I send this at that word per minute, and if you'll notice, if you watch this as these characters go by, I'll start sending pretty fast, and then you'll notice that it'll stop receiving, or look like it is. So what's happening is it doesn't, it thinks that the delay is too long in between there, so it's actually treating all those characters as just one long word. So what you do is you can tweak this down to a smaller value. So what that does is that allows for a smaller delay. So essentially, as somebody's keying Morse, you can just tweak these two values and zero in on it and kind of get it in by ear. If they're really, really good and have very regular pulses, if you have a mechanical keyboard or a really good mouse or something that you can key off of, you can use the automatic word per minute. It's also a really good way if you set this at 15 or 20 and get this kind of dialed in. This is depending on what you want to use this to make. You can actually make a pretty good Morse trainer with this as well. All right, so I believe that's it. I've just got some code cleanup and a little bit of commenting to do, and I should be submitting this in the next day or two to Unity for approval. That usually takes them about a week to 2 weeks. So hopefully in the next couple of weeks this will be available on the asset store. All right, well, if you got any questions or comments, feel free to make them down in the comment section, and I'll try to respond as I can. And I hope you guys find this useful and hope you enjoyed it. Thanks for watching.